Not long ago, 3D printers could only make simple plastic objects. Today, they can print houses, shoes, rocket parts, and even living human tissue. But that's only the beginning. Here's how we got here. In the 1980s, the first 3D printers used a laser to harden liquid resin, one thin layer at a time. Engineers called it rapid prototyping. It wasn't meant to make real products, just rough models, so you could hold an idea before building it for real. For years, that's all these machines could do. Then the materials changed. Printers learned to work in metal, in ceramic, eventually in living cells. And that single shift turned a machine for making previews into a machine for making the real thing. So what's actually being printed right now? More than most people realize. A company called Icon builds houses in Texas using a robotic arm that lays down concrete layer by layer, almost like piping frosting. A family's home rising in about a week instead of months. Adidas sells running shoes with 3D printed midsoles, a cushioning structure too complex to mold by hand. Surgeons implant 3D printed titanium bone and jaw replacements shaped from a patient's own CT scan. NASA has flown rockets with 3D printed engine parts. And in research labs, scientists have already printed small samples of human skin and cartilage using living cells for wound treatment and lab testing. That's today. Already happening, already real. So if all of that is possible right now, what comes next? Let's start with the body, because this is where things get genuinely strange. Bioprinting living tissue currently works only in small pieces. Thin skin grafts, tiny patches of cartilage. But researchers are chasing something far bigger. Full, transplantable organs. In 2019, scientists at Tel Aviv University printed a small, rabbit-sized heart using a patient's own cells, complete with chambers and blood vessels. It didn't beat. But it proved something huge. A heart can be built, not just donated. If we can already print a small model of a heart, what comes next? The real obstacle isn't shaping the organ. It's keeping it alive while it grows. Every organ needs a dense web of blood vessels, some thinner than a human hair, to feed every single cell. Printers today can't reproduce that network with enough precision, so the center of a large printed organ starves before it can ever function. This is one of the most active problems in biomedical research today, and it hasn't been solved yet. But if scientists crack it, transplant waiting lists could one day disappear, replaced by organs built from a patient's own cells with zero risk of rejection. And if an organ can be grown from someone's own cells, could a disease be treated with a medicine built for that one person alone? This has already started in a small way. In 2015, the FDA approved the first 3D printed drug, an epilepsy medication called Spraytam. Now researchers are developing printers that could sit inside a pharmacy and produce pills with a dose shaped around one patient's body. Their weight, their metabolism, their exact diagnosis, instead of the same mass-produced tablet handed to everyone. It's still early and mostly limited to pilot programs, but the direction is unmistakable. Medicine built around a person, not an average. If medicine can be personalized down to a single patient, what happens when the printer moves from the pharmacy to the middle of a disaster zone? Engineers are already testing exactly that. Mobile, industrial-scale printers have been built that can travel to an emergency site and print the solid walls of a shelter or clinic within hours, sometimes mixing in local soil or rubble as raw material. It's still in early testing, not yet common practice. But imagine a flood hitting a town, and instead of waiting weeks for aid tents, a truck arrives and prints real walls before nightfall. And if we can print emergency shelters here on Earth, what happens when there's no truck, no roads, and no air to breathe at all? That question leads somewhere much farther away. NASA has awarded Icon, the same company building homes in Texas, a contract under the Artemis program to develop printing systems that could construct landing pads and shelters using lunar soil itself as raw material, avoiding the enormous cost of launching building supplies into space. Early tests using simulated lunar and Martian soil suggest it's structurally possible. Nothing has been built on the moon yet, but the engineering groundwork is being laid right now. If we can imagine building with lunar dust, what happens when the printer stops just building the shell of something and starts building everything inside it too? Right now, even a 3D printed house still needs human workers to add the wiring and plumbing afterward. But engineers are developing multi-material printers that could lay down conductive material for electrical wiring at the same time as the structural walls in one continuous process. It's experimental, not yet standard. But picture a home that comes out of the printer already wired, needing far less human labor and far less time to finish. And if wiring can be printed straight into a wall, could it be printed straight into the object itself? So the electronics are never added at all? This is already being explored in a field called printed electronics. Scientists have successfully printed simple circuits, sensors, and antennas directly onto flexible surfaces using conductive inks. And some experimental work has embedded basic components inside an object while it's still being printed. Imagine a shoe that tracks your movement with no separate chip glued inside, because the sensor was never added. It was part of the shoe from the very first layer. If electronics can live inside an object from the moment it's built, what happens when the object itself keeps changing after it's finished? This already has a name: 4D printing. An object is printed today, and later, on its own, it transforms, triggered by heat, water, or light. Researchers have printed flat sheets that fold themselves into three-dimensional shapes once warmed, and structures that expand or tighten when they sense moisture, with no motor and no battery. It remains mostly confined to research labs for now. But think about what it could mean. A medical stent that expands by itself once inside a blood vessel, without a second surgery. And if an object can transform on its own, could it also fix itself when something goes wrong? Engineers are actively developing self-healing materials, plastics embedded with microscopic capsules of healing agent that rupture and seal a crack the moment it forms. Some already exist in early commercial coatings. Researchers are now working to combine this with 3D printing itself, so that printed car parts, printed pipes, even printed buildings could seal small damage automatically before it ever becomes a real failure. If materials can repair themselves, what happens when the object was never designed by a human being in the first place? This is already happening in engineering labs today. It's called generative design. An engineer gives an AI system a goal: make this part as light and strong as possible. And the algorithm produces thousands of structural options no human would think to sketch. The shapes that come out often look almost organic, closer to bone or coral than machinery. NASA, Airbus, and General Motors have already installed AI-generated, 3D printed parts in real aircraft and vehicles, some over 40% lighter while remaining just as strong. The AI isn't assisting the design anymore. It's authoring it, and the printer simply builds what the algorithm imagined. And if a machine can design an object and immediately build it, what happens to the idea of shipping that object across the world at all? Picture this. Instead of a cargo ship carrying identical parts across an ocean for 6 weeks, a printer downloads a digital file and produces the exact part someone needs, tonight, in their own city. Companies are already testing this model for industrial spare parts, cutting delivery time from weeks to hours. As printers grow cheaper and more capable, researchers believe home printers could eventually produce simple household items on demand. Though that's still years away, held back by cost, speed, and the narrow range of materials small printers can currently handle. Even food fits into this story. Companies have already 3D printed plant-based foods with realistic muscle-like texture. And NASA has funded research into printers that could turn raw nutrient powders into varied, edible meals for astronauts on long missions. Some researchers are exploring meals printed around one person's specific nutrition needs. It's promising, but still early, and nowhere close to replacing a kitchen. So why doesn't all of this exist everywhere, right now? Because real walls are still standing in the way. Speed is one of them. Printing remains far slower than mass production, and a printed house still takes days, not hours. Materials are another. Many printed substances still can't match the long-term strength of traditional metal or concrete. Cost stays high for anything beyond simple parts. Biology sets one of the hardest limits of all. We still cannot print blood vessels fine enough to keep a full organ alive. And regulation moves carefully, especially in medicine, where any printed implant or organ must pass the same rigorous safety testing as anything built the traditional way. A process that can take years, for good reason. None of this means the technology is failing. It means the future hasn't fully arrived yet. And every one of these walls is being tested and pushed right now by real scientists in real labs with real funding behind them. So think back to where this started. A machine that once could barely print a plastic toy. Today, it builds homes, replaces bone, may soon grow organs, and is already trusted to design its own next invention. Which leaves one real question. Not whether any of this is possible, because piece by piece, it already is. The question is what happens to a world where almost anything you need, a house, a medicine, a spare part, a meal, isn't shipped from a factory or bought off a shelf. It's simply printed, right where you are, the moment you need it. And maybe that's the moment future generations stop asking how something was manufactured and start asking why we ever did it any other way.